Okay, we're going to show you a video now about imaginary numbers, and I'm going to show you operations using imaginary numbers. Now, a lot of math teachers would probably kill me for saying this, but for the most part, at least for adding and subtracting and even multiplying and dividing, some of the basic operations with imaginary numbers are exactly the same as real numbers. I mean, if you had I plus I, you'd get 2I. So that is a legitimate operation. And so in that way, you're kind of treating the imaginary letter I kind of like X when you were first in Algebra 1, or you just began doing algebra, whenever that was. Now, the only thing that's a little different is that I is a special imaginary number, and there are ways that you can simplify I along the way. For example, if you see I squared or I cubed or I to the fourth power, or even i's to multiple powers, you can actually simplify them to sometimes real numbers. Okay, so take a look at your screen. There are 4 different versions of I. There's I to the first, which typically stands for the square root of -1. Now, if you put that in your calculator is usually not too happy with imaginary numbers. Okay, also known as complex numbers, by the way. I squared, however, can be abbreviated and simplified, and you can see on your screen that if you were to take square root of I times, or sorry, square root of -1 times the square root of 1, -1, right? So that would be 2 i's together, right? Square root of -1 times the square root of -1, you'd actually get -1. So I squared can simplify to -1. So you can replace, anytime you see I squared, you can replace it with -1. Now, if you get I cubed, that's like saying I times I squared. So that would be like -I. So you can simplify it a little bit. Doesn't look as pretty or as real, but that's okay. And then finally, the ultimate simplification is I to the fourth power, which is equal to 1. Now, you need to memorize these. There's going to be no way around it. So watch the video as I use the operations, the basic operations for combining like terms and what have you, but then also pay attention to how I simplify, and I use these 4 equivalences to make things a lot neater in my final answer. All right, enjoy the video, and I'll see you in a little bit. Alrighty, we're going to show you not 1, not 2, but 4 examples of properties with complex numbers. I'm going to show you how to add them, I'm going to show you how to multiply them, I'm going to show you how to square them, and even divide them. So let's get started here. We're going to show you complex numbers. First, a little adding and subtracting. Now, a lot of math teachers would probably kill me if I said this, okay? So just keep it between you and me. But you know how normally when you were solving algebra, if you had 2x plus 4x, you got 6x, right? You remember those days? Those were the good old days of algebra, right? Now you got to deal with imaginary numbers. I mean, come on, they're not even real. All right, just kidding. Okay, so you know that 2x plus 4x equals 6x, right? That is the same. So when it comes to adding up imaginary numbers, treat them the same way, okay? Gather up all of the constants, right? 4, 5, and 1, all the whole numbers, if you want to say it that way. Add those together, combine those, and then combine 3i with -7i. And then you'll have your answer. So 3i plus 7i, that's going to give you 10i. Right? Pretty simple. Then over here, you're going to take 4 plus 5 plus 1. 4 plus 5 is 9, plus 1 is 10. So that, my friends, is the answer for this first box. It's simply 10i plus 10. All right, pretty good. So let's move on to the next problem. And in the next problem, we're multiplying. So how do we deal with this? Well, again, just like you took x times x and you got x squared, right? you're going to take I times I and get I squared. All right, there's a little extra something that we got to do, but basically if you take 7I times negative I, you would get negative 7I squared. Now here's the hang up when it comes to imaginary numbers. I would love to say that we could just leave this as our answer and move on with our lives, but unfortunately we can't, okay? Remember that when we're dealing with imaginary numbers, I is simply a placeholder for the square root of -1. Right? That causes all kinds of problems on calculators, so we just use the letter I and then we don't have so many problems. But if you took I times I, right, if you took square root of -1 times another one, you would have -1. So I squared is actually -1, right? And that's because the square root of -1 times the square root of -1 gives you -1. Now, I could take this further, but let's just stop here for right now. We just need I squared. You'll have to memorize that I squared is equal to -1. All right, twisting my arm. I'll go a little further just to show you what else happens. If you ran into I cubed, then that would be like saying the same thing as -I, and I to the 4th is simply 1. All right, but like I said, in this particular problem, we're going to focus on the fact that we have I squared. So this means that we take -7 times -1, and then we have negative numbers that are going to cancel each other. So, whoops, we're going to have -7 times -1. That's going to make +7, all right, because the negatives cancel each other. And that's our answer for this second box. All right, yay, we're almost done, halfway there. All right, let's take a look at this one. Now, we have 8 minus 2I quantity squared, because we say quantity because of the parentheses. So what I like to do first is I like to expand the problem and turn it into a FOIL problem, because foiling will guarantee that I get all the terms in this multiplication process. So just like you FOILed quadratics in the past, you're going to FOIL imaginary numbers as well. So 8 times 8 is 64, right? We're going to go the first term, 64. Outside term is 8 times -2i gives us -16i. The inner term is -2i times 8, which is again -16i. And then finally, -2i times -2i gives us positive 4i squared. Now you may be thinking, wait a minute, I know this I squared business is not as it seems. And I would say, absolutely, right? You remember from the previous problem, I squared is the same as -1. So while we can combine some like terms, right, we can combine these two guys and make 32i, we're going to transform this a little bit, because this is really 4 times -1. Right, which we know is -4. So 64 minus 32i minus 4. Right? You could also write it as plus -4. It doesn't really matter. It means the same thing. So I'm going to combine these guys together, and I'm going to write -32i plus 60. And that, my friends, is the final answer. As a general rule, you want to write the imaginary numbers first, and then write the regular whole numbers after that. All right, we've got one more problem. Let's take a look. We're going to do some division here. And as I said before, we can treat I in a lot of ways. We can treat I like a variable. And this is another situation where we can do that. So when we have division like this, I cubed divided by I to the second, we subtract the exponents. We simply get I to the first. So if we just focused on this piece simplifies to I to the first. Now we can look at -8 divided by 2. That becomes -4. And since we have I to the first power, we really can't do anything to simplify it any further. So this is going to simply be -4I. Okay, so that's our final answer. So these are some of the properties or things that you can do with complex numbers, adding, subtracting, multiplying, dividing, foiling them, all right, which is just a fancy way of multiplication. So there you have it. If you need to practice more using complex numbers, do so. I recommend that you do, and get it down until you have it solid. All right, people, good luck, and I'll see you next time. All right, everybody, you guys are back from imaginary land, right? It sounds like the land of make-believe almost, right? When you're dealing with imaginary numbers, like somebody's like imagining some new environment there or some new world. Well, imaginary numbers are kind of like that, and there are some special rules, and hopefully you got a chance to see some of those special rules in action. But for the most part, you can treat I just the same way that you treated X as a variable. So for the basic operations, that's perfectly fine. The only problem is, since I is a little special, there are some ways that you can simplify the powers of I. For example, I squared, I cubed, and I to the fourth. Now, the way that you simplify them is on your screen, and you have to memorize these. There's really no other way around it. I wish I could tell you there was, but unfortunately, the only other trick I would have for you is to practice enough problems so that when you are using these, you use them so often that you memorize them through the practice that you're doing. And when you get to that point where it's like tying your shoelaces and you don't have to think about it, then that's when you've actually gotten to the point where you really, really know it. So if you needed some additional practice, try solving these problems again, or watch another video and see if you can get more hints and more ideas from the other videos that I have. All right, that's all I have for right now. I'll see you next time.